This video will cover notes from part 1 of the practice final exam. You'll use this practice test to review for the final exam for MAT 1033. Starting with problem number 1, we have 2x divided by x squared minus 3, or x squared minus 9. And then we're subtracting from this term 1 divided by x minus 3. Now in the denominator here, this x squared minus 9, this is a difference of perfect square numbers. Remember, when we have perfect square numbers, a squared minus b squared, where a and b represent numbers that are raised to the second power, we factor them using a minus the b term and a plus the b term. So you first got to figure out what your a and b terms are. What are you squaring in order to get this a term, x squared? We're squaring x. So our a term would equal x, and our b term would be the term we square in order to get 9. So our b term would be 3, because 3 squared gives us 9. Now substituting x and 3 in the parentheses for a minus b and a plus b, we'll get x plus 3 and x minus 3. So the denominator is factored as x plus 3 and x minus 3. 2x remains in the numerator of the first fraction, minus, here on the right side we have 1 divided by x minus 3. Now remember, this x minus 3, we have to have common denominators in order to subtract these two terms. This first fraction has x plus 3 and x minus 3. The second one has only x minus 3. So to make these two denominators equivalent, we have to multiply the numerator and the denominator by that missing factor, x plus 3 in the numerator and x plus 3 times the denominator. Now when we do that, we have common denominators. So this x plus 3 times x minus 3, we keep that denominator the same. And then we're going to combine the terms in the numerator. So 2x, carry that down, minus, here we have to distribute 1 times x and 1 times 3. So that's minus 1 times x, minus x, and then minus 1 times 3, so minus 3. We'll combine like terms, 2x minus x, we can combine those terms in the numerator, and 2x minus x gives us 1x, minus the 3, our denominator stays the same, x plus 3 times x minus 3. Now we notice this factor of x minus 3 is the same in the numerator and the denominator, so we can cancel that factor out. We leave 1 in the empty space, so in our numerator we have 1, and in the denominator x plus 3. So the answer is 1 divided by x plus 3. For problem number 2, we're distributing here the square root of 7 times both the terms in parentheses. So square root 7 times 3 gives you 3 square root 7. The square root of 7 times minus square root 7. So 7 times 7, that gives you minus square root 49. And the square root of 49 is 7. So our answer will get 3 square root 7 minus 7. For number 3, we have x to the 7th power times y in the numerator, divided by x to the 9th power times y to the negative 5th power. Now, when you see these terms that have the same base and you're dividing those exponential terms, remember you're going to subtract their powers. So our x term, we're subtracting 7 minus 9. It's top power minus bottom power. And then our y terms, we keep the base of y and we subtract. In the numerator, we want to see that y is being to the first power. So 1 minus negative 5, top power minus bottom power. Now remember these two negatives here, this becomes addition. So it's 1 plus 5, or y to the power of 6. And then for the x term, we have our exponent 7 minus 9, that gives us negative 2. Now, we have to simplify this a little bit further. That negative power, we need to make that negative exponent positive. To do that, we move it to the denominator. So x to the negative second power, we move it to the denominator, and it becomes x to the positive second power. Y to the sixth power remains in the numerator. This is our answer, y to the sixth power divided by x squared. Now, example 4, if we have this function f of x, we want to find f of negative 3. So everywhere x is, we're going to substitute negative 3. That'll leave us with negative 3 raised to the second power plus 7 times negative 3 minus 5. And negative 3 squared gives us 9. 7 times minus 3 gives us negative 21 minus the 5. So left to right, 7 minus 21, we get negative 12, minus the 5 gives us negative 17. Now, example 5, we want to find the domain. Remember, domain stands for the x terms. So we're looking for the x terms when we're given this function. We have a point here where this graph begins, and then it's an arrow indicating that it continues to go on and on forever in the direction of positive infinity. So where do our values for this graph lie as it relates to the x-axis? We're looking for a domain, so we're looking for those values along the x-axis. Here we see a starting point. It's to the left of the origin, so we would count over 1, 2, 3, 4, 5. Right here at negative 5 is where our graph begins. Now, the way that we would describe that domain using interval notation is a bracket, since the values of x could be negative 5 or any other number that's larger than negative 5. So negative 5, comma, and because we're moving in the direction of positive infinity, we put positive infinity with parentheses. Remember, you always put parentheses around infinity. That's negative and positive infinity. So the values of x lies between negative 5 and infinity. Now for number 6, we're asked to reduce this fraction. 3 minus x divided by 7x minus 21. Now, in our denominator, let's focus on this part first. We have 7 times x minus 21. We can factor 7 from both of these terms. When we factor 7 from 7x, we get x in parentheses. When we factor 7 from minus 21, we get minus 3 in parentheses. Now we notice the x and the 3 are very similar to the terms in the numerator. However, those signs are different. We could reverse this order. If I place the x term in front, that'll be negative x plus 3. Our signs are different. In the denominator, we have a positive x. In the numerator, we have a negative. So already, we want to make sure that those signs are the same, so we would factor out negative 1 from both of these terms. Actually, let's write negative 1, since we're factoring negative 1 from both the terms. When we factor negative 1 from minus x, we'll get positive x. When we factor negative 1 from positive 3, we'll get negative 3. All right, so that's what you see in the numerator. We factor negative 1 from both the terms, so we're left with the positive x and the minus 3 inside parentheses. That lets us cancel the x minus 3. And we're left with negative 1/7 as our answer. All right, let's look at number 7. So we're asked to simplify. Here we see the square root of 4 raised to the 5th power. First of all, the square root of 4, that's 2. Just plug that into your calculator. Now 2 to the 5th power, that's 2 times 2 times 2, 2 times itself 5 times, gives us 32. This is our answer. Now that problem started actually with 4 raised to the power of 5 halves. Remember the 2, that becomes our root. The base of 4 stays the same, and then the numerator becomes the exponent. So that's how we were able to get the square root of 4 from this fraction 5 halves. All right, let's look at problem number 8. We have 4 times 2 minus x. We got to distribute here. 4 times 2, that gives us 8. 4 times the minus x gives us minus 4x. That's greater than 3 times 2. We need to distribute again. 3 times 2 gives us 6, and 3 times x, that's positive 3x. Now we need to combine like terms. So we will subtract 3x from both sides of the inequality, and we will carry over the 8 and the 6, so we can collect those terms on the right side of the inequality. So we're going to subtract 8 as well from both sides. Now, when we make those changes, on the left side, negative 4x minus 3x gives us negative 7x. Bring down your inequality symbol, greater than, and on the right side, 6 minus 8 gives us negative 2. Next, we're going to divide both sides of the inequality by negative 7. And remember, when you multiply or divide by a negative number, you have to reverse this symbol. So our symbol reverses from greater than to less than. The negative 7's cancel, leaving x on the left. And on the right side, negative 2 divided by negative 7 gives us positive 2/7. Our answer is x less than 2/7. Now, in interval notation, the way we show terms that are less than 2/7 is we have a parenthesis at 2/7. You want to think about this being on the number line. That helps us with our interval notation. So x less than 2/7, if we were to graph that on a number line, let's say we had 0 here and 2/7 on the right. X less than tells us we should put an open circle at 2/7. And do you see which direction our arrow is pointing? So numbers that are less than x, we're going to shade in everything on the number line to the left of 2/7, including the arrow. In this direction, we know is negative infinity. So using interval notation, you see we have our left parentheses, we have negative infinity, comma, 2/7, and then we close with parentheses as well. For number 9, we're simplifying two terms that have the same base. We have x raised to the power of 5 halves times x raised to the power of 11 halves. So we're going to keep that base of 11, and we're going to add the powers. So 5 halves plus 11 halves gives us 16 halves. And 16 halves, we can simplify that. 2 can be divided into 16 8 times. So our answer would be x raised to the power of 8. For number 10, we're asked to graph this equation. 3x plus 2y equals negative 12. Now, one way that we can graph this equation is we can graph by placing our equation in slope-intercept form. So remember, your slope-intercept form is y equals mx plus b. So we want to get y by itself on the left side of the equation. And those are the steps we take first. To do that, we're going to subtract 3x from both sides of this equation. And that gives us 2y equals negative 3x minus 12 on the right side of the equation. And then lastly, we're going to divide everything, every term, by 2. The 2's will cancel on the left, leaving y. And on the right side, this is negative 3 halves x, so 3x divided by 2, and then minus 12 divided by 2, that gives us minus 6. Now, the slope, which is the number that's in front of your x, and the b term. So your slope is negative 3/2. That lets you know that you're going to move down 3 spaces since that numerator is negative. Remember, your numerator tells you which direction to move on the y-axis. So either you're going to go up or down. If your sign is negative, you move down. If it's positive, you move up. And then the denominator tells us how we shift along the x-axis. So either we're going to go to the right or to the left. We go right if our number is positive, and we move left if that bottom number is negative. So negative 3/2 tells us to move down 3 spaces and to the right 2 spaces. Now, we always start with our y-intercept. Our y-intercept is -6, so we plot this point first. So here, we're going to go to 0, and then we're going to shift down 6 spaces. Shift down 6 spaces on the y-axis. 1, 2, 3, 4, 5, and 6 right here. Once you plot that y-intercept, then you're going to use your slope to find another point. So from -6, you're going to go down 3, right 2. So down 1, 2, 3, right 1, 2. And plot the second point, and then connect those 2 points to create the graph. Now, problem 11, what is the equation of the horizontal line? So think about our axes, and let's not get these confused. So we want to know the horizontal line that goes through this point, 7, -2. So if we're at 7, -2, we're going to go to 7 on the x-axis, 1, 2, 3, 4, 5, 6, 7, and then down to -2 on the y-axis. So right 2, that's x-axis, 7 spaces, and then down on the y-axis 1, 2. Here, plotting that point. This is the point of 7, -2. Now, remember, this point was created based on where it crossed the y-axis and where it crossed the x-axis. Here we cross the x-axis at 7. We cross the y-axis at -2. Which of those represent the horizontal line? It's this line, the horizontal line that runs through -2 on the y-axis. So that equation should be written as y equals -2. Now for number 12, we're asked to rationalize this denominator. That means get rid of the square root. To do that, we're going to multiply the square root of 3 times the numerator and denominator. Whatever that denominator is, if that would have been the square root of 5, we would have multiplied the numerator and denominator by the square root of 5. That's how you get rid of the square root, multiply it by itself. So when we multiply in the denominators, square root 3 times square root 3, we'll get square root 9. In the numerator, we have 2 times square root 3. The square root of 3 can be reduced. The square root of 3 is 3. So this is our answer, 2 square root 3 divided by 3. Now number 13, we got to find the equation of the line that goes through this point, 4, 5, and that has a slope of 2. So we could use that point slope form of an equation. Remember, point slope form we learned as y minus y sub 1 equals m times x minus x sub 1. And this 0.45, we're substituting that x coordinate as our x sub 1 and the y coordinate as our y sub 1. Remember, slope is the same thing as using variable m. So in our equation where we see m, we're replacing that slope we were given of 2. Our x sub 1, we're replacing that with 4, and then our y sub 1, we're replacing with 5. So instead of y minus y sub 1, we got y minus 5 equals our slope 2 times x minus 4. Now we can simplify this a little bit further. On the right side, we're going to distribute that 2. 2 times x gives us 2x. 2 times the minus 4 gives us minus 8. And on the left side, we have y minus 5. Now we can simplify this a little bit more, put it in slope-intercept form. If we add 5 to both sides of the equation, the 5's will cancel on the left side, leaving y equals, and then 2x minus 8 plus 5, that gives us minus 3. So this will be our equation. Y equals 2x minus 3. Example 14, we're graphing this equation or this inequality, and the inequality isn't written in slope-intercept form. We don't have y by itself on the left side. So we're going to subtract 3x from both sides of this inequality, and we'll get y on the left side less than negative 3x plus 4. Now, we're using the slope and the y-intercept to graph the line. You always start with your y-intercept. Our y-intercept is 4, so we're going to move up 1, 2, 3, 4, plot the point. And now our slope is negative 3, which can be written as a fraction by putting negative 3 over 1. Now that negative 3 tells us we're going to move down 3 spaces, and the 1 in the denominator tells us to move to the right 1 space. Starting at our y-intercept, which was 4. So starting at 4, we're going to go down 1, 2, 3, and to the right 1. And then you connect those 2 points to create the graph of the line. Now looking at 15, we see a compound inequality. That's when we have more than one inequality symbol. Our goal is to get 5 or get x by itself. We're going to get rid of the 5 eventually, but get x by itself in between these 2 inequality symbols. So we want to look at that inequality symbol as separating these terms into 3 sections: the middle section, the right section, and the left section. Now, all 3 of these sections, whatever operation we perform, we must perform that same operation with all of the sections. So in the middle, on the right, and on the left side. First, to get x by itself, we're going to start with the term that's not attached to the variable. So we're going to add 3 to the right side, the left side, and the middle. That'll cancel the 3's in the middle, leaving 5x. On the right side, 12 plus that 3 gives us 15. And on the left, negative 12 plus 3 gives us negative 9. The last thing we want to do is divide both sides, or all 3 of the sides, by 5. Now when we do that, in the center, our x is left by itself because the 5's cancel out. On the left side, negative 9 divided by 5 gives us negative 9/5. And on the right side, 15 divided by 5 gives us 3. We got negative 9/5 minus x minus 3. So x is between these 2 numbers, negative 5 and positive 3. And that's how we would write that solution in integral notation, using parentheses. Negative 9/5, comma 3. So x is between this range. For number 16, 5/3 raised to the power of negative 2, we're going to distribute that power to each of the terms, numerator and denominator. So that leaves us with 5 to the negative 2nd power divided by 3 to the negative 2nd power. Now we got to get rid of these negative powers here. That 3 to the negative 7th power, or negative 2nd power, we move it to the numerator and it becomes positive. And then 5 to the negative 2nd power, we move that to the denominator to become positive. Both of these terms can be simplified. 3 squared, we get 9 in the numerator, and 5 squared, we get 25 in the denominator. This is our answer. For number 17, we want to draw a line with an undefined slope. So the line that has an undefined slope is a vertical line. So you can just draw a line up and down. Any vertical line has a slope that is undefined. Now you also need to know which line has a slope that's 0, and that's when you see a horizontal line. For number 18, find the domain. This time we have a fraction. Remember, to get the limit, we need to know when is this denominator going to be equal to 0. So we take our denominator and we set it equal to 0. 10 minus 5x. When is 10 minus 5x equal to 0? We'll solve for x to find out. So the first thing you want to do is subtract 10 from both sides of the equation. And that'll leave you with negative 5x equals negative 10. 0 minus 10 leaves us with negative 10. The last thing we want to do is divide both sides of the equation by negative 5. And x equals negative divided by negative is positive. 10 divided by 5 gives us 2. So when x is 2, the denominator is equal to 0, and we can't have that. We cannot have a value of 0 in the denominator. Therefore, x cannot be equal to 2. We want any other value for x except 2. So that's how we would represent our solution. X such that, values of x such that x cannot be 2. Number 19, we have scientific notation in the numerator, 6.3 times 10 to the 25th power, divided by 3 times 10 to the negative 8th power. First, looking at the integer or the decimals here, 6.3 divided by 3, that gives you 2.1. And then 10 to the 25th power divided by 10 to the negative 8th power. You keep your base and you subtract the powers. Top power, which is 25, minus bottom power, which is negative 8. And remember the negative and negative, 25 minus minus, that becomes a plus. So that's just positive 8. 25 plus 8 leaves 10 to the power of 33. And the 2.1 stays in front, but this is our answer. 2.1 times 10 to the 33rd power. Now number 20, and this is the last problem from section 1. Which of these graphs represent a function? To determine if a graph is a function, remember you're going to perform this vertical line test. And that means just draw vertical lines through the graph. And you want to make sure that your vertical line touches the graph at only one spot. See how this line touches the graph at 2 places. So that means it's not a function. Here, the line touches the graph in 2 places, the top and the bottom. So again, this is not a function. However, in the last graph, if we draw vertical lines, we touch the graph only at 1 point. So that means that this is a function. So no, no, and yes. And we'll stop here and pick up with part 2 of the final exam review immediately following this section.